Okay, so what we're going to have here is equality of equations. Okay, so an example would be equality of complex numbers. So for example, if I had two numbers here like a plus bi equals c plus di, what we see is that these two complex numbers are equal. So the real part equals the real part, so a has to equal c, and therefore b has to equal d. Another example would be if I said that's 3 plus 4i, this would mean that a equals 3 and b equals 4. So what we're going to do with the equality of complex numbers, in these equations we're going to remove the brackets, we're going to label r under the real parts, I under the imaginary parts to identify them, let the real parts equal the real parts, the imaginary parts equal the imaginary parts, and solve these resultant equations, usually by simultaneous equations. So an example would be, we'll go for number 3. So look at number 3 here, we're going to multiply it out, and we're going to get 3x, and we're going to multiply that out, and we're going to get minus xi, minus yi, minus 5i. Then we're going to get this equal to this side, which is going to be I, plus 3i squared. Now 3i squared is the same thing as minus 3. And then on this side we're going to have 6, and then we're going to have minus 2y. Now let's look at the real numbers on both sides and the imaginary numbers on both sides. So this is a real number, and these two are real numbers. Well, these two combined make the number 3. So what we're going to get straight off the get-go is we're going to get 3x equals 3. That's the real equation. Now we're looking at the imaginary numbers. Oh, sorry, excuse me. I also forgot this real number here, the minus 2y. So we're going to get 3x equals 3 minus 2y. Then we're going to get 3x plus 2y equals 3. And that's the real equation. Now we're on the imaginary equation, and that's a 1i. So what we're going to get is minus xi minus yi minus 5i equals 1i. Now the i's don't need to be there, it just needs to be the imaginary parts more than anything, so the i's can disappear. And what we next have is minus x minus y minus 5 equals 1. So bring that over to your side, and we're going to get minus x minus y equals plus 6. What we're then going to do is we're going to solve these two equations here. So I'm going to multiply this one by 2. I'm going to get minus 2x minus 2y equals 12. And then I'm going to find out that x equals 15. And what does it say? X, y, element r, so x equals 15. And we're going to figure out what y is. So y, if we look at this equation here, it's going to be minus 15 minus y equals 6. In the 15 over the other side, we're going to get minus y equals 21. Y therefore must be minus 21. So next, moving on to question 8, we have set 1 is 5 plus 7i, set 2 is 3 minus I. If k times set 1 plus set 2 equals 16 plus t plus 2i, find t and k, where tk is element r. Okay, so what we're going to do is we're going to get set 1 plus set 2 first, which is going to be 5 plus 7i plus 3 minus I. And what we're going to get here is 8 plus 6i. So this part here is going to be 8 plus 6i. Okay. Then upon completion of that, what we're next going to do is we're going to multiply that out with the k. And we're going to get 8k plus 6ki. That has to equal 16 plus ti plus 2i. Now we're going to label what's real. 8k is real, no y in that. 16 is real. So what we're going to get is 8k equals 16 for the real equation. For the imaginary parts, we're going to get 6k equals t sorry, that's imaginary, excuse me, imaginary, 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 and I'm going to get t plus 2. So k equals 2, therefore 6k is 6 multiplied by 2, which is 12, 12 equals t plus 2, t therefore equals 10. So there you have it, 10 and 2. Okay, now we're going to move on to question 11. So on question 11, what we have is set 1 is 6 minus 8i, set 2 is 4 minus 3i, pi is equal to set 2 plus l times set 3. Find p and l where set 1 plus set 3 equals set 2. Move to set 3 to the left, to set 2 to the right, and we're going to get set 3 equals set 1 minus set 2. Let's find out what set 3 is, because we need it in this equation here. So set 3 is set 2, which is 4 minus 3i. That's going to be minus 6 minus 8i. Then put it in, we're going to get 4 minus 3i minus 6 plus 8i. Then we're going to get 4 minus 6, which is minus 2, minus 3i plus 8i is plus 5i. So minus 2 plus 5i. Once we have this information here, what we're next going to do is we're going to use this set 3 information and put it into the pi equation. And we see this pi equation here. So p times i ends up to be set 2, which is 4 minus 3i. And then plus l times set 3, so it's l going to be multiplied by minus 2 plus 5i. That will give me minus 2l plus 5li. And that happens there, so just rub that part down. Then just drag this part down. Oop. So maybe not, so it's going to be minus 2l plus 5li. So there we go there. Now, just have to mark what's real and what's imaginary. So in this full equation here, it has no real on this side. So the real side, the real value is 0 over here. The real value is 0, the imaginary is p. So the real equation, which I'll do in green, is 0 equals real, which is 4. This one's real as well, minus 2l. The imaginary equation is p equals minus 3 plus 5l. And what we're going to do is solve this. 2l equals 4, l equals 2. If l equals 2, p equals minus 3 times 5 times 2, which is plus 10, p equals 7. So 2 and 7. So this answer here actually disagrees with the back of the book. Now, what happened with this was just a quick mistake was made here, okay? When I did set 1 minus set 2, I was meant to I got my set 1 and my set 2 actually mixed up. So what I was meant to do was meant to turn these the opposite way around. Very easy mistake. So 6 minus 8i minus bracket 4 minus 3i. So what I should have got instead was 6 minus 4, which is 2. 8i plus 3i is minus 5i. And then in turn, this gets multiplied by L. So L should have been getting multiplied by 2 minus 5i, which is going to be plus 2L minus 5Li. So basically they're the same ending, but just ever so slightly different. So then we move that up here. So then what we should have got was for the real equation would have been 0 equals 4 plus 2L. 2L goes over the other side, come minus 2L equals 4. L equals minus 2. And then for the imaginary equation, it would have been P equals 2 minus 5, or sorry, minus 3 minus 5L. P therefore equals minus 3 minus 5 minus 2, and it gives you P equals plus 7. So it is minus 2 and plus 7. Okay. So for question 12 now, we're going to do okay, so next question here is question 12. Okay, let u equal 1 plus I. Write 6 over u in the form x plus yi. So it's going to be 6 over 1 plus I. We got to multiply that top and bottom by its conjugate, as remembered. So we're going to get 6 minus 6i on the top, and then on the bottom we're going to go 1 minus I plus I minus I squared, and minus I squared is plus 1, and then we're going to get 6 minus 6i all over 2, which is 3 minus 3i. So 3 minus 3i. X is 3, y is 3. Now part 2, a and b are real numbers such that a multiplied by 6 over u minus b into u plus 1 and 3 into u plus 1. Find the values of a and b. So what I need to do here is write down u. U is 1 plus I, therefore u plus 1 is going to be 1 plus I plus an additional 1, which is 2 plus I. Now need to put this in. Now we're going to use our 6 over u from before, so it's going to be a into 6 over u. 6 over u is 3 minus 3i. And then minus b times u plus 1. U plus 1 is 2 plus I. And that equals 3u plus 1, which is going to be 3 times 2 plus I. Now, going to multiply all this out. What we're going to get is 3a minus 3ai. We're going to get minus 2b minus bi. And then we're going to get 6 plus 3i. Now we're going to identify our real equation. That's real, that's real, that's real. So 3a minus 2b equals 6. Then we're going to go imaginary. Minus 3a minus b equals 3. So minus 3a minus b equals 3. I'm going to multiply this one by, I'm just going to leave it as is actually. So we're going to get minus 3a minus b equals 3. Add them directly down to two different equations, and then we're going to get minus 3b equals 9. B therefore equals minus 3. Now b is equal to minus 3. What we're next going to do is replace b with minus 3. So minus 3a minus minus 3 equals 3. Then we're going to get minus 3a plus 3 equals 3. Then we're going to find out that minus 3a equals 0. Therefore a equals 0. So it's going to be a is 0 and b is minus 3. Okay, so that's the correct answer for that one. Now we're on to question 14. So, in question 14, what we're going to have is w equals p plus qi is a complex number, so that w multiplied by its conjugate minus 2i times w equals 7 minus 4i. Find two possible values of w. So, what we're going to get is w equals p plus qi. Its conjugate is going to be p minus qi. Then we're going to multiply w by its conjugate, so we're going to get w conjugate. So we're going to get p plus qi multiplied by p minus qi. And what we should get here is p squared plus pqi minus, minus pqi plus pqi. Minus pqi plus pqi, and then minus q squared I, and minus q squared I, q squared I squared is going to be minus q squared times minus 1, which is plus q squared. So we're going to get is p squared plus q squared. So this whole part here is p squared plus q squared. This is going to be minus 2i times w, and w is p plus qi, equals 7 minus 4i. So what we're going to get here is p squared plus q squared minus 2pi minus 2qi squared, which is plus 2q, which is going to be 7 minus 4i. Then we're going to have two equations here, so we're going to have real, 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 and real. So we're going to have p squared plus q squared, p squared plus q squared plus 2q equals 7, and then we're going to have minus 2p for our imaginary, minus 2p equals minus 4, p therefore equals 2. Now that we know that p equals 2, what we're going to have here is p squared is going to be 4, q squared plus 2q equals 7. We sort of have a quadratic equation going on here, so we're going to end up with q squared plus 2q. That's going to be 4 minus 7, which gets you minus 3. You're then going to solve this quadratic equation as q plus 3, q minus 1 equals 0. Then you're going to have q equals minus 3 and q equals 1. Two values for q, one value for p. Remember, the complex number is p plus qi. So there's two answers, okay? So p is going to be 2 and 2, and one of them is going to be minus 3i and the other one is going to be plus 1i. And there's our two complex number answers. Okay, so now it's on to question 16. Question 16, find the values of a and b where the element r. I'm just going to multiply this out, so we're going to get a squared plus ai minus 3bi minus b squared I squared. B squared I squared is plus b squared. And then we're going to get 10 plus 10i. So we can see this is this question 16 multiplied out. Then we're going to allocate the real values, so real, real, and real. So we're going to get a squared plus b squared equals 10. And then we're going to have the imaginary one, which is a minus 3b, also equal to 10. So we have a quadratic equation and a linear equation. So what we need to do is, using the linear equation, get one letter on its own. So a equals 10 plus 3b. Substitute this into the quadratic, so we're going to get 10 plus 3b squared plus b squared equals 10. Multiply it out. 100 plus 30b. This is just 10 plus 3b multiplied by 10 plus 3b. We can all multiply that out. It's 30b plus 30b, but the 30b plus 30b gives you 60b. Then we have our 9b squared here, plus our b squared. And then I'm going to take over that 10 to minus 10 equals 0. Then what we're going to get is 10b squared plus 60b plus 90 equals 0. We're going to divide by 10 and we're going to get b squared plus 6b plus 9 equals 0. We're going to factorize this, and we're going to get b plus 3 bracket b plus 3 equals 0. And then what we're going to find out is that b equals minus 3. Now that we know that b equals minus 3, we need to figure out what a is. A is 10 plus 3b. A therefore is 10 into 3 times minus 3, which is a minus 9. 10 minus 9 is 1. A equals 1. And therefore b equals minus 3. Now we're on question 18.